have a mountain. Someone's on top, someone's at the bottom. So what's the difference between them? Elevation, good. Okay. So try and draw the best you can what I'm drawing here. Okay.
Yeah.
Okay. Those are air particles. Those are air particles.
Isn't it harder to breathe? Okay.
You're gonna ruin all my fun. So, the particles at the bottom. Now, just to clarify, they're supposed to be the same number of particles. It's just that there's a lot of these kind of crowded together, whereas up here they're spread out. So the only way to really show that accurately is if I'm going to count. I'm not going to count. Or to just draw more particles kind of over on the side, but that doesn't really fit in your notebook. So imagine these particles are up here, but they just spread out. All right, that's the part you kind of have to just assume. I can't really draw that completely accurately. Okay. All right, so those represent air particles. Think of oxygen particles, maybe, because that's the part that we're really focusing on here. So now, Reagan, go ahead. What were we going to say?
Well, I was going to ask if it's harder to breathe on a high elevation.
Yeah, I don't know. If you climb Mount Everest for some reason, because it's there, do you know? Do you need an oxygen tank to breathe on the top? Yeah, you do. Now, you can train your body to breathe. So it is harder to breathe at higher elevations. Okay? In some mountains, you can't breathe at all on top without help. An oxygen tank. You can train your body to get used to it, and you can breathe better at higher elevations than normal people. Sometimes professional athletes train in Denver because Denver's higher in elevation, and it helps their lungs become more efficient. So then when they come back down closer to sea level, it's almost like they have super lungs. So they can be in even better condition. So training at high elevations you can train your body to be a little bit more adaptable to that environment. But certain elevations, and I'm not an expert, so I don't know like at what point is it. Doesn't matter what you do, you won't be able to breathe. But you keep going up in altitude or elevation, eventually you can't breathe. Why? Let me ask you this question: what causes air pressure again? Is that recording? Or is it just like,
Yeah, it's recording.
it is like there's a number on top?
Yeah.
Okay. Sometimes I set it up and then I don't actually hit the button. What causes air pressure again? Colliding in particles. So raise your hand if you think you know, down at the bottom with Nicole and her candle, or up at the top, Reagan and her basketball, where is there greater air pressure? Or higher air pressure? Raise your hand if you think you know. Where is there higher air pressure? At the bottom, sea level, or at the top? Is your hand raised? Go ahead, Nicole. Yes, down here, I want you to write high air pressure. Or higher. Higher air pressure. The air pressure in this room, we're not sea level, okay? But the air pressure in this room, we're going to just assume that's here, okay, is pretty close to 1 atm. You guys have your reference tables out, right? Right. Go to the front, look at table A. Reference table A. Standard temperature and pressure. Do you see where it says pressure and underneath it says 1 atm? 1 atmosphere, that's a pressure. What's another pressure on that chart? 101.3 kilopascals or kPa. That's pretty close to the pressure in this room. All right? So that's like normal. Well, if we started to climb up a mountain, okay, the air pressure up at the top would be much lower air pressure. And if you kept going until you got to space, there's basically no air pressure. So let's say the air pressure up here is like 0.2 atm. Okay, so it's 1 atm down here and 0.2 up there. And again, if you kept going up, up, and up away from the ground, closer to space, there's even less air pressure. There's even less air particles, sort of. What's happening to the air particles? So they're very condensed down here, but up here, they're expanding. Have you ever heard the air is thinner?
Yeah.
That's why. All right, because the air is spread out. So if each one of these particles is oxygen gas, right? We need that to breathe. All right. Here you don't really have to do much. You can just breathe because there's a lot of oxygen right in front of your face. It's very concentrated, all right, in front of our face. But on top of Mount Everest, for example, the particles are really far spread out. So the only way to breathe would to use an oxygen mask, or you'd have to be Pac-Man. Get it? You guys know what Pac-Man does? Yeah, you have to go around and eat up all the oxygen. Okay? Eat up all the oxygen, but you wouldn't be able to do that. Alright? If you can move it like the speed of light, maybe, and you could capture enough oxygen to breathe, but because it's spread out, it's not in front of your face, you can't breathe. Alright, here's the question of the day. Why is the air thinner? Why does it expand? Think for 30 seconds. I'm going to call somebody. Why is the air thinner? Why does the air expand the higher we get away from sea level? The larger the altitude, the higher the altitude. 30 seconds. Okay, that was 30 seconds. Anybody have a thought? Go ahead. It's colder. What happens to gases when you cool them down? Are you sure? They condense. Good try.
So I was wrong.
Well, yeah, I mean, yeah. If it's cold, if it's colder, they should get closer together. Does that make sense? Okay. I know what you're looking at. Yeah.
I mean, this is probably like really wrong, but like you're closer to like outer space, so like where it's like no oxygen.
Yeah. Okay. Why?
Because like there's no oxygen molecules like.
Oh, so you're saying there's like no oxygen up on top of the mountain?
No, I mean like you're getting closer.
You're getting closer to no oxygen.
Yeah.
Okay. Stay on Earth. Okay. Why does the air spread out? Think of it. I know what you're saying. That's.
Is it because we have different atmospheres, and the higher you get, the closer to a different atmosphere you are?
Ooh, you're close. I'm gonna have to tell you because the bell's gonna ring here. Here's why. It's hard to see, but stay with me. Give me 30 seconds here. If you're this is not a great example here, but as you go higher and higher and higher, there's less layers of atmosphere pushing down on you. The analogy would be, let's say you threw Zeke on the ground, and then we all piled on top of him. Okay, and I got to be on top, and I just stood on top. If I'm standing on top of all of you, do I feel any pressure from above? No. Who's going to be basically crushed? Zeke. So the closer you are to sea level, the more pressure from the layers above force particles together. The further up you go, the less you feel that pressure.
Is that kind of like the ocean as well?
Sort of, yeah, yes. So like people in the middle of our stack will feel less pressure than the people at the bottom. Does that make some sense?
Yeah.
So that's why the air is thinner on top of Mount Everest.